This is a very interesting question because it's really testing our understanding of standard deviation, and it's not testing whether we know how to find a standard deviation. And so that's interesting because I've seen people who actually know how to compute a standard deviation but get this question wrong, and people who have no idea how to compute a standard deviation and get this question right. Because again, it's not about knowing how to compute it, it's about understanding what a standard deviation really measures conceptually. So what does a standard deviation measure? It's a measurement of how spread out the numbers are in a data set, in a set of numbers. In other words, it's measuring the average size of the gaps among the tick marks on the number line. So if there are many large gaps, you'll have a large standard deviation, and if there are fewer and smaller gaps, you'll have a smaller standard deviation. That's really all we need to know in order to answer this question. You see, we're told that the standard deviation of this set is 20, but then each of the tick marks on this number line for this set gets multiplied by 0.8, and it also gets moved to the right or to the left. I'm not really focused on that part of the question because that doesn't impact the distances among the data points. And that's probably the most important point in this question, so let me repeat that. Adding or subtracting some constant to every single tick mark in a set of numbers on the number line will have no impact at all on the distances among those tick marks on the number line. Multiplying each of them by 0.8, on the other hand, will have an impact. What impact? If every number in the data set is multiplied by 0.8, the gaps among the data points will also get multiplied by 0.8. And if we think and try to visualize why that is exactly, think about what it means to multiply. When you're multiplying a number by 0.8, you're taking that number's distance from 0 and multiplying that distance by 0.8 to get the new distance. So if you're taking every one of those distances from 0 and shrinking them all by 20%, right, multiplying them by 0.8, if you imagine looking at this through a camera lens, you're zooming out by 20%. Like all of the distances that were there, now they're 20% shorter. You've shrunk the whole story by 20%. And so if every one of the distances from 0 shrinks by 20%, that means that the distances among the tick marks will also shrink by 20%, which means that the standard deviation will also shrink by 20%. So that initial standard deviation of 20 is getting multiplied by 0.8, and therefore the correct answer is 16. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.